All right, welcome to section number 4 of Unit 4, and this is helpful hints. So, helpful hints so that you can get this done. The first one here is we have a population tripling every hour. So it doesn't matter what the population is. So it could be like 1,000 bacteria. It's going to triple in 1 hour. So the starting is 1,000. I just made up 1,000. It could be any population. It doesn't matter. And then it triples 3 times as much, and then for 1 hour. So what's going to be the multiplying factor if it's a half an hour? Well, you're going to put in 1/2 in for that spot. So we're going to multiply by the 3 with the new power of 1/2 instead of 1 hour. So you're going to do 3 to the 1/2 power. That would be for a half an hour. So you got to find the 2 answers that represent that. Well, here's one, and there's one more. Number 2. This is talking about medication. The half-life of medication is 4 hours, and it's 225 milligrams. So we got 225 milligrams. That's my starting point. And then we're starting at noon. Write the expression medication in milligrams. So it starts at noon. There, it says noon right there. So it's 1 hour later. Well, it's the thing where it doubles, or it cuts in half every 4 hours. So you would say, okay, it's going to go from 125, half as much in 4 hours. It's one time period of 4 hours. It's going to cut it in half. So this 1 represents 4 hours. So we want to do it from noon until 1. Well, that's only 1 hour later. So the exponent isn't 1, it's a different fraction. So what's the different fraction going to be? And then this one here is 7 hours later. So it's going to be a different fraction than 1. So 1 means 4 hours. So 1 hour would just be like 1/4, right, of the time. And then the trick, and then the 7, so we need an exponent for that. All right, and then down here, it's 225, and it's the 1/2 power. And this needs to be in fourths. So 5 over 2 is equal to 10 over 4. So 10 fourths. So because it's 10 fourths, you can tell that it's 10 hours later. So it's 10 hours later. Later from what? It's 10 hours later from noon. So we can tell that what time of night it is, right? So that it wants to know that. All right, the next page, it's kind of the same idea. It's 1 year, it's going to be 10% more. So each year it's 10% more. So it does, the number of employees in the company, and again, it doesn't matter how many people there are in the company. So you could say 1,000 people, 1.10 to the first power, right, would be 10% more after 1 year. So again, we're just trying to figure out the multiplying factors. This is what's the multiplying factor if it's 1 month? Well, 1 month is 1 part out of the year, so it's 1/12 of the year. So this first one here is the multiplying factor would be 1.10 to the 1/12 power. So this up here, right, that's would be at the end of the year. So 1 represents 1 year. Here, on this problem, 1 right there represented 4 hours. So that's why we said we have to do different fractions for it. Here, 1 month means 1/12 because 1 is for an entire year and a month is just 1/12 of a year. So you can kind of use that logic and fill in these two. All right. The next one here, we have to figure out the rate of decay for an entire decade. So a decade's 10 years. So 1 here represents 10 years, 1 decade. We got to find the change. So to do that, we take 24,000 divided by 40,000. Okay, and that's going to be how much it went down. So 24,000 divided by 40,000 is 0.6. So if we multiply the 40,000 by 0.6, we get 24,000. So it's a loss of 40%. The multiplying factor is 0.6. So my function is going to be f of d is equal to 40,000, right, or starting. And then it's 0.6, which I got by figuring out the rate at which it goes down. And then d represents a decade. Well, a decade is 10 years. So if you're going to do a problem, that's less than 10 years, right? Like 4 years, that's a fraction of a decade. So the fraction of the decade needs to go in for D. So think about what that means. And then what is the change for each year? Well, this is where you solve this equation. You start off with 40,000. Start off with $40,000. And you're going to do B to the 10th power. And you're going to do that 24,000 like that. So you're gonna divide first by that, and then you're figuring out that would be the change for each year. So it's not a lot of change per year, but it's 40% change over 10 years. All right, so when you solve that equation, that'll be the change for each year. Okay, next page. This is the stock market, and it says it increases 8% a year. So you don't do like 8 times 10 and get 80. That's wrong. So what you have to do is you have to say, okay, well, if it goes 1.08 for each year, a change for 10 years, and you type that into the calculator, you get 2.158. So 8% change in a row. And again, we could pretend that we have any amount of money in the beginning. It doesn't matter. So you could say, okay, $1,000 or whatever. It makes no difference. It's just going to be 2.158 times larger. So if you do multiply by 1.08, 1.08 10 times more, it's going to be over 2 times as much. If you think about an 80% change, an 80% change would be 1.80. For the 1 decade would be 1.80. So changing 80% by the decade would be 1.8, whereas for each year, if you did 8% more, it's way more than an 80% change. It's over 100% change. So then you can answer which one is bigger. These are T's and F's, so just put a false or a true. And then here, you need to know the equation from this section here. So the equation, you may not remember it, you have to have $300, that's your starting amount. And then it's 1 minus the increase. Well, what's the increase? Well, it's going up 4.5%, so it's 1.045. That's the common ratio. And you're going to do that 20 times over 1 minus 1.045. All right, that's what so what you do is you put the starting amount here. The starting amount goes there, and then the common ratio, the R, goes there, and then the number of times you do it goes there. So it's the starting amount 1 minus whatever the common ratio is to the number of times you do it. So it's 20th power because it's 20 years, and then 1 minus the common ratio. That's a formula we used way back in Unit 2. So you type that in, and you can get one of the answers, A, B, C, or D. All right, so those are your helpful hints on Lesson 4.